In this video, I'm going to show you how you can run a multicollinearity test in R and SPSS. First and foremost, we are going to install these packages. You need a set of packages. So let's install the first package. If you've not installed this package, you have to install these packages in R. I've already installed all these packages in R, so I don't have to install them all over again. Then you use the library function. Using the library function, you run this line of code that activates the particular packages. So I've already installed that in R. As you can see, I already have that in R, and also I already have the other one in R as well. I have all those packages already installed in my R. So, and the last one is the perform packages. So if you haven't installed those packages, you have to install those packages in R. So the next in which we are going to install we are going to install the other package we are going to install is this package. I'm installing this package because of the pipe function I want to use in R. Okay, you run that line of code. If you haven't installed the package and that install the package. Now let's import our dataset. My dataset is an Excel spreadsheet, so I'm making use of this code to import the dataset. Now you can see that. So when I click on this, you can see my dataset. This is my dataset. I have a lot of columns, a lot of variables, but my variable of interest are the sales and the type, the engine size, and what else again? The fuel capacity represented by the MPG. So this dataset deals with the sales of cars. And I want to look at the influence of the sales of cars based on the type of car, the engine size of the car, and also the fuel efficiency, okay, of the car represented by the MPG. Now, since I have a lot of variables, I want to select that particular variable. So since I have a lot of variables, I want to select my variables of interest. So I want to select all my variables of interest. Then I have to introduce the pipe function and use the select. And these are the variables I'm interested in. I'm going to pass the variable to that and run this kind of code if everything is done properly. Now you can see that only these variables are now selected. So I can now rename this. Okay, I can name it we're looking at car sales multicollinearity. So you can say car underscore sales multicollinearity. Okay, I can save that in that object known as car sales multicollinearity, and I run this line of code. I save that in that object. So now I have that car sales multicollinearity. Now you can see I only have these 4 variables now selected. All the other columns has been dropped. So now I want to run the regression. So I have to install this particular package, the LN test. So if you haven't installed that, you do that. Then I need the library function. The library function will help me to activate that. So having installed that, the next thing is to run the regression analysis, and then let's say let me call that model equals to LM. Now LM, I can use the formula Now, formula my dependent variable is sales, so I want to see the influence of the type of cars, engine size of cars, and the fuel efficiency of the on the sales of cars. So that is my dependent variable. So I have to introduce this and the data. What is the name of my data set? So this is the name of the data set. So these are all the variables I need. So that is the coefficient of a model. So these are the estimates of a model. These are estimates. Then if we want to see the significant value, the error time, and I'm able to find innovative model for significant. Sometimes we can run this regression this other way around. We could remove all this and just signature X equals LM. No, let me see why we are having this issue. Also, another way we can do this, since we have more than one variable, we can just run this with that. So in order to check for the multicollinearity problem, then we have to install this other function, this other package. We have to install this other package known as performance. Okay. Now I've already installed that in my app. All you need to do, you have to install it if you don't have that. Then you run this line of code to now check for multicollinearity. Then what you have to use the check multicollinearity function. You have to use this function and you bring in the R. You run this particular line of code that checks if there is multicollinearity but could not find the function check multicollinearity. Okay. We made a mistake, check collinearity. Just give me now. When you look at the collinearity now, you can look at the dataset now. The low correlation and the correlation is low. Now, if the correlation is high, it will have indicated that the correlation is high, but currently it's telling us the correlation is low. Now, in order to detect if there's a problem, if there's a problem of multicollinearity with a model, we look at the variance inflation factor. A variance inflation factor that is greater than 2 indicates that there's multicollinearity in your dataset. But here it's telling us that multicollinearity, there's no multicollinearity in our dataset. Okay, and we can also look at the tolerance value. The tolerance value that is closer to 0, the more closer the tolerance value is to 0, indicates that the more the data set might have the problem of multicollinearity. In other words, the more our data set might be affected with the problem of multicollinearity. Multicollinearity. Now we can see that this tolerance value is not closer to 0, and then we can see it's not closer to 0, not closer to 0. So that's that there is no problem of multicollinearity in our dataset. So in order to do this in SPSS, what we need to do is to run this regression, a linear regression model, and weight efficiency, engine size, and the type of vehicle. Now we run this, and we ensure that this is checked for collinearity diagnostics, and click on continue. You click on OK. Now, our focus is on this. Now, when we look at, we can see that this vehicle type is significant, just as what we got using the R. The R. So the tolerance value, you can see our tolerance value here. The tolerance value is not really closer to 0, and we can see the variance inflation factor. Though this is greater than 2, but is less than 10. Some argue that the variance inflation value that is from 10 upward indicate multicollinearity problem. Now you can see the variance inflation factors, that they are not greater than this value of 3, and the tolerance value are not so close to 0. So that's to say that there is no multicollinearity in our model. Our model is not suffering from the problem of multicollinearity. Also, when you look at the engine values here, the engine values here also helps to indicate the problem of multicollinearity. The more closer it is to 0, the more multicollinearity it implies. There is multicollinearity in our data set. But in all, we can confidently conclude that our data set based on the tolerance value and the variance inflation factor has no problem of multicollinearity in the model.